Bismillah Rahman Rahim. In this session, we will discuss statistical diagram. There are two types and pictograms. Bar charts and pictograms are used to represent data that is divided into different categories. Bar chart, we can see that the number of families having number of children. So there are 12 families have 10 families have 2 children, and 3 families have 3 children, and 2 families have 4 children, 2 families have 5 children, and 1 families have 6 or more than 6 number of children. So this is the way that bar charts used to represent the data. Similarly, pictograms can be used to represent MP3 players. The pictogram shows the people's favorite color in their MP3 players. This complete circle represents 2 people. So red 11. So 11 are red, blue are 13, and yellow are 14. Similarly, greens are 15. And this dark blue purple is 9, and others are 5. So this half is representing the value, MP3 values, by summing all values. So this is just an example, and we'll solve now exercise 42.1. Question number 1. Amira drew these pictograms to show the number of books borrowed from school library 1 week. So on Monday, or one book representing this pictograms representing 10 books. On Monday there are 3 pictures, so there are 30 books. On a Tuesday we have 3 complete pictures and a half book. So this is 30 plus 5 is 35. On Wednesday this is 20 plus 5 is 25. On Tuesday 40, and on Friday it is 55. So how many books they are borrowed on each day? On each day this is 30, 35, 25, 40, and on Friday 55, because Friday is the most popular. Which day was the most popular? Friday, because there were it was weekend, and 55 books were borrowed. On question number 2, the bar chart shows the eye color of a student in class 10F. These are the different colors: green, brown, blue, gray, and others. How many students have brown eyes? So there are 7 students have brown eyes. How many more students have blue eyes than gray eyes? Blue eyes, 10 students have blue eyes and 7 students have gray eyes. So the difference is 3. So there are 3 more blue eyes students as compared to gray eyes students. How many students are there in the class? So there we will sum all. So this is students are there in the class. So we will add all. This is 5 plus 7 is 12. 12 plus 10 is 22. 22 plus 7 is 29, plus 1 is 30. So there are 30 students in the class. We can read it from this bar chart, and we did the same in this example here. So the total number of students is 5 plus 7 plus 10 plus 7 plus 1 is 30. Now question number 3, the table shows the number of students absent from school during 1 week. On Monday 8 students were absent. On Tuesday 5 were absent. On Wednesday 7. On Thursday 10. On Friday 6. So we will show this 8, 5, 7, 10, 6. This is 8, 5, 7, 10, and 6. So on Monday 8 students were absent. On Tuesday 5. On Wednesday 7 students were absent. On Thursday 10 students were absent. On Friday 6 students were absent. So this is the way this bar chart representing the data. Now question number 4, the table shows the number of bikes sold by a shop in 4 weeks. In week 1, 12 bikes were sold. On week 2, 10. week 3 19, and week 4 is 13. One bike, this picture, this symbol use 8 bikes. This symbol representing 8 bikes. Here in this circle there are 8 sector, 1 2 3 4 5 6 7 8. So 8 sector representing 8 bikes in a complete circle. So we will show this in this question number 4. Here we have one in week 1, 12 number of bikes were sold. So in a pictogram, this is complete circle with 8 sector, and this is half circle with a 4 sector. So this is 8 plus 4 is 12. So this pictogram representing this 12 frequency. In a week 2, 10 bikes were sold. So this is complete circle is 8, and this is 2 sector, which is quarter circle, is 2 plus 8 is 10. In a week 3, 19 bikes were sold. So this is 8 plus 8 is 16, and plus 3 sector 1 2 and 3. So this is 19. In a week 4, 13 bikes were sold. So this is 8, and this is 1 2 3 4 5. So this is half and 1 sector. So this is 5 plus 8 is 13. So this is all from exercise 42.1. Bismillah ar-Rahman Rahim. In this session we will discuss exercise 42.2, that is on pie chart, and here we have question number 1. The table shows the length of 16 pea pods, and the length is in millimeters, and the frequency or occurrence is 6. So for 55 to 59 there were 6, or 60 to 69 mm length there were 20 pea pods, and for 70 to 79 14, 80 to 89 12, and 90 to 99 is 8. So, and the total frequency is, so there were 60 pea pods, and the occurrence of length in a different region is 6, 20, 14, 12 and 8. So we have to show this different lengths in a pie chart. So we have 6, 20, 14, 12, 8 and 60. So we'll divide it in a pie chart. So pie chart is another way to display the data from table frequency, or here in this exercise the length of 60 pea pods, or a 60 frequency, 6 frequency, we have sector 36 degree. For 20 frequency, 20 divided by total frequency into 360 because of circle is 120 degree. For frequency 14 it shows 84 degree. For 12 it shows 72 degree. For 8 frequency it is 48. So we will show this 6, 20, 14, 12 and 8 in this region. So this is 6, which is 50 to 59 mm length, is representing in this pie chart with this sector. For 60 to 69 there are 20. So 120 degree will show this represent. This is 120 degree. This is 60 to 59, and then 14, which is 84 degree. This is 70 to 79 mm length, and then 12 upon 60 is 72 degree. So this is 72 degree, 80 to 89 mm, and for 8 upon 60 this is 90 to 99 mm, which is 48 degree. So in this is a pie chart which is representing this table, frequency table, in terms of pie chart. So we have this question number 2. The pie chart shows the first letter of the names of 200 students. So the number of students are with different letter initial letter names are representing in this sector. So there are 200 students is equivalent to 360 degree angle. So what was the most common letter? We can see the most sector area is A, covers a most area, so the most common letter is A. How many students started with P? This sector representing P. So, and this sector representing V, which is almost half. So we will solve this question number 2 here. The pie chart shows that the first letter of the name of 200 students, the most common letter A, the name of the student start with P. So let's the degree is if we measure with protractor, let's suppose this is 36 degree. So if this is 36 degree, then we can write down 36 degree in terms of 200 divided by 360. So this 36 degree corresponds to this 20 students. So the letter P, the name of student with letter P, there are 20 students are there in the class, started the name with letter P. If there are total 200 students in a complete circle, then this P part representing this 36 degree is equivalent to this 20 students. Similarly, if V is half of this P, then there are 10 students. This letter V, there are 10 students in this pie chart. V and P. Now question number 3. Nasreen did a survey to find the number of bedrooms people had in their home. The pie chart shows their results. So what fraction of people had 3 bedrooms? So let's say if it's supposed as 120 degree or slightly more than that, so we can say this is 120 degree or 150 degree. Suppose this is 150 degree. So this is 150 degree, we can write it 150 here. So 150 divided by 360 means 5 upon 12. So this is 150 degree divided by 36 degree, 360 degree. This is 150. We can write it 150 here. So in a part B, 16 people had 2 bedrooms. This is 16 people have 2 bedroom in their home. How many people did she ask altogether? So if this representing 16 people, this 2 bedroom, this purple color representing 16 people, then this complete circle should represent some values, which is x. Let's say, suppose that is x, then we can solve it like this. So 16 people have 2 bedrooms. 2 bedrooms set is equal to, let's suppose that portion is 80 degree. So 80 degree divided by 360 degree multiply by total people in this pie chart is equal to 16. So 80 is equivalent to 80 degree representing 16 people. So x people representing 360 degree. So this x is representing 360 degree, and this 16 by 80 x by 360 degree. So we can solve it, simplify, and we have obtained this 2 by 9 x is equal to 16, and x is equal to this 19 by 6 into divide by 2, 17. So there are 70 people were asked in the survey. If this gray portion, the purple portion representing 16, then this complete circle represents 72 people. This is part B. So this is question number exercise 42.2. In the next session, we will discuss 42.3, where we will discuss grouped and continuous data, frequency diagram. Bismillahirrahmanirrahim. In this session, we will discuss about representing grouped and continuous data that is used. One way is a frequency diagram, and this is frequency diagram is like a bar chart, but the axis uses a continuous scale. In a bar chart, we have spaced scale on the axis to represent the bars, but in a frequency diagram, the axes are continuous scale. So this is the main difference. And there is another way which is called a frequency polygon. This is another way to represent the group continuous data. In a frequency polygon, a single point is used to represent each group. So in this there are 2 ways, frequency diagram and frequency polygon. So we will discuss in the next exercise, that is exercise 42.3, and here we have the question number 1. The manager of a sports center recorded the ages of the women who used the swimming pool one morning, and here are his results. Draw a frequency diagram to show this data. Age 15 to 20, frequency is 40, 20 to 25, 12, 25 to 30, 17, 30 and less than 35 is 6, 35 less than 40 is 8, 40 less than 45 is 3, 45 less than 50 is 12. So this is the frequency diagram and table, and we have to draw a frequency diagram. So this is so for 15 to 20 we have this value which is 4, and for 20 to 25 this is 12, for 25 to 30 we have this 16, 17, and for 30 to 35 we have 6, and 35 to 40 we have 6, 7, 8, and for 40 to 45 we have 3, and 45 to 50 is 12. So this is 12. Right? And 2025 again we have 12. 2025 we have 12, and 45 to 50 again we have 12. So there are 2 times 12 frequencies, and this is all represented here. This is a frequency diagram. There is no gap. All frequencies are closed on the axis. So there is no gap in a different classes. So this is continuous range. In a question number 2 we have a survey. In a survey the annual rainfall was measured at 100 different towns. Here are the result of the survey, and 50 less than 70 is 14, 70 90 33, 90 less than 110 is 27, 100 centimeter less than 130 is 8, 130 less than 150 is 16, 150 less than 170 is 2. So we will draw this frequency diagram and write down the model class. So model class can easily be seen from here. That 70 to 90 is a model class because this is 33. The highest frequency is a model class, and which interval contains the median. So we will see the median class as well. So this all is 100. So this 14 plus 33 is 47, and in this band a median will be here in 90 to 110 because the 50 frequency will be here. So 50 and 51 will be here. So the median will be here. This median value will be here in this range. So this is question number 2. Let's solve it. Question number 2 for annual rainfall. For 50 to 70 this is 14, this is 32 or 33, this is 27, this is 8, this is 16, and this is 2. So all these ranges are plotted here in this frequency diagram, and the model class is this one because the highest frequency, and interval contains the median value. The sense of frequency is 100 total frequency, so the median frequency should be around 50-51. So we will add 14 plus 33 and 27. So this 47 and plus 27. So in this 27 band here, in this band the median class will be there. Here in this band, in this interval the median class will be lying. In question number 3, the frequency diagram shows the ages of people on a train one morning. On a one morning the ages of the people were recorded, and we see in a frequency diagram. This is a frequency diagram, and to make a group frequency table from this data. So we, in the previous two questions, the tables were given and we have to draw the frequency diagram. In this question number 3, we have given a frequency diagram and we have to draw the table. So for 20 to 30 we have 1, 30 to 40 we have 4, 40 to 50 we have 8, 50 to 60 10, 60 to 70 7, 70 to 80 is 5, and 80 to 90 is 2. So 30 to 20 is greater than or equals to 20 and less than 30 is 1, 30 to 40 is 4, 40 to 50 is 8, 50 to 60 10, 60 less than 70 is 7, 70 less than 80 is 5, 80 less than 90 is 2, and total frequency is 37. 1, 4, 5, 13, 23 plus 7 is 30, 35 plus 2 is 37. So total frequency is 37. Model class is having a highest frequency, which is 50 to 60 because of the highest frequency. And the third part is explain why the youngest person may not be 20 years old. In this band we say that youngest person may not be 20 years old because the frequency is just 1 and in whole band a single person lies. So there is a possibility that the single person is not be at 20 years old. The frequency is the range of 20 to 30 is 1 and the youngest person may not be a 20 years old. So this is one of the reasons. Question number 4. The ages of all the people under 17 in small villages were recorded in 1995 and 2015. The results are given in the table. So these are the ages, these are the frequencies in 1995 and in 2005. On the same grid, draw a frequency polygon for each year. So we have to draw the frequency polygon on a same diagram, on a same frequency diagram polygon. We have to draw the frequency polygon on the same grid and using the frequency polygon to compare the distribution of the ages in the 2 years. So this table has to draw on the frequency polygons, and frequency polygon we take the mid value. From 0 to 10 we should take a 5, in 10 to 20 we take 15, 20 to 30 we take 25. So we will draw it like this. So the frequency polygon in 1995, this is 0 to 10 is 5. At 5 we have this value, and then this we have plotted this polygon for this range. 85 on 5 and 15 we have 78, on 25 we have 70, on 35 we have 53, on 45 we have 40, on 55 we have 28, on 65 we have 18. So we have draw these values on different. Single point is used to represent that the polygon. So this single point, the midpoint, and we draw this frequency polygon. And similarly for 2015, this 5 is representing 50 at 5 position. We have a 50 value. This is 50 at 5 position, and then 15 we have this some value 52 or something, 51, and then at 25 we have 78, 25, this 25 we have this 78 value, and this is something less than that, which is 76 or 75, 76, and then 62, and then similarly this. So we can see that in 1995, this is representing 1995, the low age people were high, and the old peoples were in low numbers, while in 2015 the low age people were low and middle age people were slightly higher in 2015 according to this survey. So in 1995 the young population was higher, however in 2015 the middle age population is higher. So the middle age population is higher in this band. So this is what this frequency polygon representing in this question number 4. In the next session we will discuss scatter diagram or correlation related problems in exercise 42.4. Bismillah ar-Rahman ar-Rahim. In this session we will discuss scatter plots or exercise 42.4. Has the first question. The table shows the math and science marks of 8 students. A to H is 8 students. Student 1, 2, 3, 4, 5, 6, 7, 8. 8 students have different marks in math and in science. So we have to plot these marks to show the results. So draw a scatter diagram to show this information with the math marks on the horizontal axis and physics marks on the vertical axis. Describe the correlation shown in the scatter diagram. Draw a line of best fit and then use this information to estimate some values. So first draw the scatter diagram. So we have 10 marks at math and 30 marks at science. At 10 we will plot a 30 here, the first one, and then at 20 we have 28, 20, and this is 28. 96 have 80. At 96 we have this 80 at 96, and then 50, then 55. At 50 we have 55, 50 we have this 55 marks. At 80 we have this 62, 80 we have this 62 marks. And then 70 we have 70 marks, 70, and here we have 70 in science. And 26 and then 38. 26 is there, and then 38. 26 and 38 is this one, and this 26 we have this 38 marks. And finally 58 for 48. 58 in maths, 58 is here, 58 in maths, and 48 in science. This. So we have this all data plotted corresponding to science marks and math mark, and with this data points we have plot a straight line to show the best fitting, and we can see on the graph this is a strong relationship because these are close. So and the one marks in one subject is increasing and the other marks on the other subject is also increasing. So there is a strong positive correlation is representing in this data, and the best fit is placed here in a draw a line of best fit, and we have placed the best fit line here that is all close to the all data points. And in the D part we have to science marks, we have to obtain the science marks while the math marks is 40. So if math marks is 40, then science marks is around 42 or 43. So this is from the graph. Similarly for math marks have to obtain if the science marks is 75. If science marks is 75, then we can draw this 88. At this 75 we have this dotted line which is 88. So this 88 marks. So this can be read if we have a proper graph paper, we can do it very accurately. So this is just a rough working. So a student have to perform all these activity on a graph paper. Similarly, the question number 2, the table shows the amount of fuel left in the tank of a car after different numbers of kilometers traveled. After traveling, the fuel consumed, so the number, the liters left in the tank is decreasing. So after 20 kilometers, the fuel is 7 liter. So after 40 kilometer travel, 5.2, 60 kilometer travel, 4.2, and after 120 kilometers, the fuel left is 0.4 liters only. So we have to plot this. On one side we have to show the number of kilometers, on the other side we have to see the number of liters left in the tank. So this is the fuel tank level or liters, amount of fuel left in the tank in terms of liters, and this is the number of kilometers traveled. And we see that at 20 the value is 7 liters, at 40 it is 5.2 something, at 60 it is 4 point something, 4.2, and at 82.6, and at 10 is 1.2 or 3, 1.2, and at 120 it is 0.4. So we have these values plotted and we have draw a best fit, and at that best fit we have to find one answer. Best fit, use the line of best fit to estimate the number of liters left after 70 kilometers. So at 70 kilometers we have to see the amount of fuel left is around 3.4 or 3.5 liters. Similarly, question number 3, the table shows the marks of 15 students taking paper 1 and paper 2. So there are 15 students marks, paper 1, paper 2 marks of different 15 students, and we have shown this. Both papers were marked out of 40. So paper 1 maximum marks is 40, paper 2 maximum marks is 40. Draw a scatter diagram to show the information. So we have to draw information on the scatter diagram. So we have used all these data. On x-axis we have plotted the paper 1, on the y-axis we have plotted paper 2, and draw these plots. And from drawing all these plots we can see this is a very widespread data. So we can see that this is a weak positive correlation. Although the numbers are increasing, the number increasing on one paper, the paper number increasing on the other paper is also increasing, but here we have large variation. So this is weak positive correlation, and on a diagram we have draw a best fit line that is close to all data points. So this is shown here, and this is just an estimation. One of the student named Joy, paper 1 score is 32. So this is 32 in paper 1. We have to estimate the marks in paper 2, which is almost equals to 32. So the same estimated paper 2 marks is 32. From the graph we can plot it, we can read it from the graph as well. So this is something like this. So this is all from 42.4. In the next session we will discuss cumulative frequency diagrams, and Bismillah Rahman Rahim. In this session we will discuss the cumulative frequency diagram. Cumulative frequency diagram is one of the way to display the large set of grouped continuous data. Large set of grouped continuous data are used to represent through this cumulative frequency diagram. It can be used to estimate the median of the data and to give information about the spread of data. Median of the data and how the data is spread can also be seen through this cumulative frequency diagram. So we will discuss this in exercise 42.5, and here in this 42.5 the table shows the time taken for the 200 runners in a race, and here we have this table 0 to 60, 0, 60 to 80, 10, 80 to 100, 37, and 180 to 200 is 1. Similarly, to make a cumulative frequency table for the data, so we have to make a cumulative frequency from this table and draw a cumulative frequency diagram. After formulation of a table, cumulative frequency table, we will draw a cumulative frequency diagram, and then we will estimate some values less than 90 minutes and more than 150 minutes. So let's solve this question number 1. Cumulative frequency table, time in minutes, and cumulative frequencies for this is 0 to 600, 60. So we will, time is less than 60, we will place it like this, 0, and the lowest band will be considered. And for time is less than 80, so this will be covered as well here. So this less than t 80, 0 to 80 will cover this 10, and in time less than 100, 0 to 100, all will be covered here in 47. So we will add all frequencies here. So 0 and then 3, and 3 plus 18 is 21. Similarly, this is this one, 0, and this is 10, and then plus 37 is 47, and then 47 plus 72 will increase similarly. So we'll add this one, 0, 10, 47, and then 47 plus next one is added, and 119, and added the next one is then become 174. And similarly with this cumulative frequency, the eventual frequency reach to this 200 value, and we will draw this. So we will draw this diagram here. At 60 we have 0 value, at 60 we have 0 value, at 80 we have 10 value, 10 frequency, 80 we have this 10 value. This is cumulative frequency, and here we have a time in minutes. And at 800 we have this 47, at 100 we have this 47 value, at 120 we have 119, and at 140 this is 174, at 160 192, at 180 199, at 200 we have this. So we will plot this like this. So here in this part we have to ask a question. We have draw the frequency diagram, we have draw a table. Now estimate less than, the number of runners who took less than 90 minutes. Who took less than 90 minutes is very low, less than 90 minutes. So less than 90 minutes is 22, just 22, 90 minutes at this 22, and for less than 90 minutes is 22, and this is the value for more than 150 minutes. So at 150 minutes we will draw this here, and from this table this value is 188. So more than 150 minutes, take this such groups. So 200 minus 188 is just 12. So for t greater than 150 minutes is the number of runners is, because t less than 150 is 188, so t greater than 150 is 200 minus 188, which is equals to 12. So 12 runners took more than 150 minutes, which is represented on this cumulative frequency diagram. Next question is the table shows the length in hours of the lives of 90 lamp bulbs, and we have to draw a cumulative frequency table, cumulative frequency table, and then diagram, and estimate the number of lamp bulbs that lasted for more than 680 hours. So from the given information, we have draw a cumulative frequency at 0, 3, 21, 50, 75, 88, and then 90, and we draw this here. At 600 we have this value 0, at 625 we have 3, at 650 21, at 675 50, at 775, at 725 88, 725 is 88 here, 88, and 750 is 90. So 750 is at 90 is here. So we draw this diagram, and this is the cumulative frequency diagram, this is cumulative frequency table, and in the last part, C part, estimate the number of lamp bulbs that lasted for more than 680 hours. So we will draw the line on the 680 hours. So this is 675, so this is correspond to this. Here we have 700, so this is 680. At 680 we see that 55 lamps, so lasted more than 680 hours. So we have to see this batch band. This takes less than 680 hours, and this part takes more than 680 hours. So we'll take this part. So we will subtract this 55 from this 90 to get this 35. So 35 lamps will last more than 680 hours, because 55 bulbs last less than 680 hours. So the remaining 35 bulbs will last more than 680 hours. So this is simple. This is part C, and we solved it here. In the next session we will discuss median, quartiles, and percentiles. Bismillah ar-Rahman ar-Rahim. In this session we will discuss median, quartile, and percentile. A cumulative frequency diagram can be used to find the median value of the distribution, and median also called 50th percentile, and lower quartile of the data is the 25th, low quartile of the data is the 25th percentile, and upper quartile is the of the data is at the 75th percentile. And the difference between this 25 to 75 is called the interquartile range. Is a measure of the spread of the middle 50% of the data, and interquartile range is equal to upper quartile minus lower quartile. So we will show this information in next exercise 42.6. The table shows the distribution of the height of 120 people. The height is 130 centimeters, and the number of people is 0, 130 to 40 is 4, 5, 140 to 150, 12, 150 to 6, 160 is 26, similarly 190 to 200 is 4. So we will draw a cumulative frequency table for the data and use it to draw a cumulative frequency diagram. So we will draw a table and then cumulative frequency diagram, and using this information to answer this following question: the median height, the lower quartile, upper quartile, and interquartile range. So let's solve this question number 1. So height is this: 1830, less than 130 is 0, less than 145, less than 150 is 17. We add the frequencies, so we will add this here. So this 5 and this 5 plus 12 is 17, and similarly the next one will increase, and the next one will increase to 43, and similarly we will reach 120. And this cumulative frequency tables are drawn from the given table, this table frequency diagram distribution table, we will draw a cumulative frequency diagram, which is here. And from this cumulative frequency table, we will draw this here. At 130, 0, this is 130, 0. At 145, at 140 we have 5. At 150 we have 17, 150, 17, 160, 43, here. At 170, 78, here. At 180, 101 is here. And at 190, 116 is here. At 200, 120 is here. So we plot this, and this is the first table part, and the second one is this. And from this we use this data to find the median height. So the median is at the 50th percentile is the median. At this is 120, so the mid frequency is 60, and from this 60 we can draw this median height is 166, 160, 170, so it should be 166 centimeter. In the second part, we have to find the lower quartile, that is at 30, which is 157 centimeter, and in the upper quartile at 90 frequency, which is 172 centimeter. So the upper quartile and lower quartile difference is interquartile. Upper quartile minus lower quartile is 172 minus 157 is 15 centimeter. So this is the band between this lower quartile and upper quartile is 15 centimeter. This is a part 4. So this is all from this question number 1. In the next question, we have given a cumulative frequency table shows information about the mass of the 200 potatoes. This is the mass of the 200. This is a cumulative frequency table is given, and we have to draw a simple frequency diagram. And from the diagram, use diagram to estimate the median and interquartile range and estimate the 80th percentile. So we will solve this in part 2. Question number 2 here. So we have used this table to draw this cumulative frequency table, and from this we have the median value is because we have 200. At 100 we have a median values. At 100 points we have this median value, which is around 168 grams. So the median mass is 168 grams. So this is part 1, and at lower quartile is because we have 200, so it should be 50. At 50 we have this LQ value 115 grams, and upper quartile means adds 150, which is 205. So 150 is 205, and at 80th percentile, which is around 160. So at 160 we have a value 215 grams. So all can be answered from this cumulative frequency diagram. At 50 value, at percent, at 50% means frequency is 100, and 25% frequency is here in this 200 frequency is 50, and upper quartile frequency is 150, and at this corresponding mass of the potato is given, and 80 percentile mass potato is given as 215 grams. So this is all from this cumulative frequency diagram. So this is simple, not very difficult. So the 80th percentile. So this is not 80th percentile, which is 215. This is 80th, 80. So 0 is missing here. So this is 80th percentile. And the third question. Cumulative frequency table shows information about the yield in liters of milk from 120 cows, and the less than 5 cos gives no, and up to 5 cos gives no milk, 10 up to 10 cos gives 10 milk, 15 gives up to 15 gives 33, and up to 35 gives 120. 120 cos gives up to 35 liters. So up to 5 liters gives no 0, up to 10 liters give 10, 33 cos gives up to 15 liters. Similarly, 120 cos gives up to 35 liters. So we have been given a cumulative frequency table, and we have to draw a cumulative frequency diagram from this, and use this diagram to estimate the median and interquartile range of the amount, estimate the number of the cos that produce more than 28 liters of milk, estimate the 20th percentile. So we will solve all this here in question number 3. Cumulative frequency diagram, we plotted this frequency diagram, and this part 1 is a cumulative frequency diagram. In the part B, we have an upper quartile range at since the value is 120, so the upper quartile is 3, lower quartile is 30, and upper quartile is at 90. At 90 we have this value, upper quartile is 23.5 liters, lower quartile is 14.5 liters, so the interquartile range is 90 liters, and 107 cos give at 20 for more than 28 liters. For more than 28 liters we will draw this line. So we see that the frequency is around 107, so there are 13 cos left that gives more than 28 liters. So only 13 cos gives more than 28 liters of milk. So this is from the cumulative frequency table, interquartile, upper quartile, and at a particular point of the number of cos gives number of liters correspond to the number of the cos. So question number 4, the cumulative frequency diagram shows the distribution of the speed of 100 cars on each of the 2 roads. So this is red road, this is road A, and this blue color is road B, and on which road are the car traveling faster. So we can see that the minimum speed is higher, maximum speed is almost same, the frequency is same, the speed is high. So in this range the speed is increasing, so its minimum speed and maximum speed is both high, and median speed is also very high. Here the median speed is around like this, and here we have this. So we have solved this in here. Median speed of the road A is low, interquartile speed of road A is here, interquartile speed here and here, and interquartile speed range is this, and interquartile speed here and here. Here the interquartile speed range is small. For this red is interquartile speed range is a little bit high, range is larger. We can just draw it UQA, in upper quartile road A, lower quartile road A, large spectrum, and median speed of road B is high, interquartile speed of road B is upper quartile, lower quartile of B is small. So we can see this all from the table, and the car speed is faster on road B. Road B is faster, evident from the median speed. The median speed of road A is low, and the median speed of road B is high. Similarly, the car speed is consistent on road B because the interquartile range is quite close, so the road B speed is consistent. So interquartile range, here we have this 40 speed, this here, and 120. So this. So the speed difference is between 70 to 90. So this is very close. So the speed on the here we can read it from here at 25 and at 75. So we can read this big value, and similarly for this one at 25 and at 75. So the road A interquartile range and road B interquartile range can be estimated, and the car speed is faster on road B and car speed is consistent on road B, because the speed is quite close. Interquartile range is small on road B, so spread is small, that's why the speed is consistent on road B. In question number 5, we have given cumulative frequency diagram show the distribution of the masses of 160 boys and 160 girls. So the cumulative frequency is 160 for both boys and girls, and here we have the masses weight measured of the girls and boys. The median, so median 160, 80, at 80 here we can read it, at 80 we can read it. So from table we can read it. Here is median of the girl is 62 kg and the median of the boy is 79 kg. It is easily be read from this table. At 60, at 80 here at frequency, this is the girl's median value, and yes, here 62, and here we have this is 79. And similarly for the interquartile range for 40 and at 120, difference will be read from here and will get. Similarly for this 40 here and for 120 here, in this we can give the interquartile for the boys. So the interquartile for the boys and girls is this. So interquartile for girls is upper quartile, lower quartile 71 kg minus 52 kg is 19 kg. For interquartile of boys is upper quartile 89, lower quartile 66, all from the cumulative frequency diagram. And here we have this interquartile range is 23 kg and here we have 19 kg. In the C part, the girl masses range is from 34 to 96 from the graph, and the boys mass range is 40 kg to 100 kg, 112 kg. And lower quartile of girls is less than lower quartile of boys, and upper quartile girls is less than upper quartile of boys. So these are the comments or the some of the information or inferred knowledge from this table. So make 2 comments. So we have given this comments here. So this is all from the graph, and this is all from exercise 42.6. In the next session we will discuss the histogram, exercise 42.7 from this statistical diagram. Bismillah Rahman Rahim. In this session we will discuss exercise 42.7 about the histogram, and in question number 1 we have given 200 people were surveyed to find the distance they travel to work. So the commute distance is here, 0 to 5 is 3, 5 to 10 is 9, 10 to 15 is 34, and 60 to 100 is 20. So we will use this information to draw a histogram to show this information. So this is part 1, and we have given this distance and frequency, and we have to find the class width. 0 to 5 is 5, and frequency is we have to find the frequency density. So we will divide this frequency by the class width to obtain the frequency density. So this is class width is 0 to 5, and 5 to 10 is 9, 10 to 15 is this, and similarly we have redraw this here, this information, and then the class width is 5, 5 to 10 is class width is 5, 10 to 15 5, 15 to 20 is 5, 20 to 30 is 10, 30 to 40 is 10, 40 to 60 is 20, 60 to 100 is 40. So we will divide the frequency by the class width to obtain the frequency density. So we will divide this 3 by 5 to 0.6, 9 divided by 5 is 1.8, 34 divided by 5 is 6.8, 49 divided by 5 is 9.8, 17 divided by 10 is 1.7, 41 divided by 10 is 4.1, 27 divided by 20 is 1.35, 20 divided by 40 is 0.5. So this is frequency density, and here we have a class width. So we will plot it here in a histogram. This is class width. For 0 to 5 we have 0.6. So class frequency density is 0.6 here. This is 0.6, and in the next gap 5 to 10 we have this 1.8. So 5 to 10 we have this 1.8. In the next section we have 10 to 15 6.8. So 10 to 15 6.8, and in the 15 to 20 we have 9.8. So 15 to 20 we have this 9.8. In the 20 to 30 we have 1.7. 20 to 30 this is 1.7 here. In 30 to 40 we have 4.1. 30 to 40 4.1. In 40 to 60 1.35. 40 to 60 we have 1.5. In the 60 to 100 we have 0.5. So we have this 0.5. So this is the histogram we have plotted. This was asked in question number 1. In the part 2, question number 2, draw a table shows the result of the survey to find the areas to the nearest hectare of 160 farms. So this is the area. Hectare 1 to 4 is 29, 4 to 8 is 18. So this is the frequency diagram table we have given, and we have to draw a histogram. So we have to draw a table of frequency density. So using this same table in the in part question number 2, we have area in hectares 1 to 4, 4 to 8, 8 to 12, 12 to 16, and the frequencies are given, and we will take a class width is 1 to 4, 4 to 8, so this is 3. This is wrong. Actually this is 0 to 4. I think why okay, this is 3. So the width is 3, so this is wrong. So we should make it 3. So this is 3. So this should be a little higher. So we did a mistake here, so we can correct it by 3 here, and we'll divide this 3 and then we get something. Plot it, that will be different. So, and the next part is okay, we did a mistake here. So this is 3, and 4 to 8 is 4, and 18 divided by 4 is 4.5, and this is 4, 12 to 4, 8, 4, and 34 is the frequency. You divide this, will get this. 26 divided by 4, 6.50. 28 divided by 8 is 3.40. 8, 11 divided by 6 is 1.38. Yes, here we have width is 4. So 8 divided by 4 is this. 40 and 34 is 6. So 6 divided by 6 is here we did a mistake. This is 3, so we'll divide this 3, and we have a different density. Otherwise everything is correct except this first part, because this 1 and 4 is 3. So we'll divide it by 3 and we'll have a different value here, and we'll plot it accordingly. So this value will be a little higher, and the rest is same. In the next question number 3, the age of each person on a bus was recorded. The table shows the result: 0 to 10, 10 to 20, 20 to 30, 30 to 40, 45. So we have this values. So draw a histogram to show this information. So this is 0 to 10 is 10 class width, this is 10, this is 10, this is 15, this is 5, this is 20, this is 30, and the frequency is given as this. So we'll divide this class frequency divided by this class width, and we will have this frequency density here, and we have plotted this histogram accordingly. For 0 to 10 we have 0 values, so 0 to 10 no class width, and 10 to 20 we have this 0.2, 10 to 20, and 20 to 30 we have this 0.3, and 30 to 45 is 0.533, so 0.533, and 45 to 50 is 1, here 1, 45 to 50, and then 50 to 70 is 0.9 is here, and then 70 to 100 is 0.4. So this is 70 to 100 is 0.4. This is 100. So this is the histogram for this question number 3. So in first 3 parts we have drawn a histogram. In the question number 4 and 5 we have this graph. We have given this histogram, and we have to answer here. How many students took between 15 to 25 minutes to travel from home to school? So from 15 to 25, this is 15 and this is 25, and it is the frequency density is here. This is 8, and this is the mid value is between 8 and 9. 8 and 10 is 9, so this is 9. 9 multiplied by class width is 15, and 25 is 10. 10 multiplied by 9 is 90. So the 90 students took 15 minutes to 25 minutes to travel home from school. In a part A, the question is very easy. Work out the total number of students asked, the traveling time. So we will take the class width into frequency density. So obtained a total frequency. So we have to obtain in a part B, we have been asked a total frequency. Total number of students asked means total number of frequency. So we multiply the class width with the frequency, class width, frequency, density, class width, frequency density, class width, frequency density, class width, frequency density, class width, frequency density. So we will get this. In part A, frequency density, class width was 10 and the frequency was 9, so the 90 for 15 to 25 minutes. Total frequency, so the class width into frequency density for the first band, 5 into 2, 10 into 18, 10 into 9, 15 into 8, 30 into 3. So we'll add all, and the total frequency is 490. So 490 students were asked that how long they take to reach to their home in a different histogram band, which is shown in this diagram in question number 4. So estimate the number of the students who took between 30 and 60 minutes. So from 30 to 60 minutes. So we'll take this band and this from this. So 30 to 40 and multiply by the frequency width. So 30 to 60 we have 2 intervals, 30 to 40 and then 40 to 60. In a 30 to 40 we have class width is 10 and frequency density is 8 from the graph histogram, and from 40 to 60 we have a class width of 20 and the frequency density is 3. So from 30 to 60 we have this class frequency, and from 40 to 60 we have this frequency. So total frequency from 30 to 60 is 140. So this part C is very, very important. Because here the area is different for this one and area for this one is different. This area up to this, and here we have this area. So this is part C. Now question number 5, then the member of the gym club were weighed. The histogram represent their masses. So this is the masses of this is the histogram, and how many members of the gyms were weighted. So we have to calculate the total frequencies in a part A and calculate an estimate of their mean mass. So we have to calculate the mean mass and how many. So we have to calculate the total frequency from this histogram. So the part 1 is total frequency. Total frequency is equal to class width into frequency density multiplied the every class width with the frequency density, and we have obtained the total frequency is equal to 100. So this total frequency is 100, and afterwards we have to find the mean value, mid frequency. Mid frequency is 100. If the total frequency is this, then the middle frequency should be 100. So we will multiply. The first one is 6, 12, 18. This is 18 plus 12 is 30, 36, and in this band 31. So this 20 to 1.55. So in this band the median frequency will lie, mid frequency will lie. So the mean lie at the mid frequency, that is 50. So we will add this 6 plus 12 plus 18 and this x into 1.5. So this is the class width into the frequency density. So class width into frequency density, and this is the class width will be used. So this class width is basically x part of that width equals to 50 frequency. So this is 36 and this is 1.55x plus 50 is equal to 50. So subtract is 14x divided by this. So this is 99 kilogram. So up to this value, this is 70, 1, 2, 3, and this is, and afterwards the frequency 9 kg increases to obtain a median frequency which lie in this band around here. So the median, the mean frequency is around 79 kg because of this class widths. So we will take a portion of this width and will multiply this. This is 79, so it should be around here. So if we look at the diagram, we can estimate that the area is half. If we take this 79 here, this area and right and left area should be equal. It's look like the same. So this is question number 5C, which is very, very interesting. B, where calculate or estimate the mean mass. So that's all from the statistics.